Hi, and these are the solutions to the preparation sheet that was sent out earlier in the week. So first of all, we've got a topic on two-event probability. So on this sort of topic here, one of the things to do is to actually write down what outcomes there are. So we've got a fair five-sided spinner with the numbers 1 to 5 on. So equal chance of landing on a 1, 2, 3, 4, or a 5. And at the same time, simultaneously, we are going to toss a fair coin. So it's got heads or tails on there. So the first thing that we are going to do is we are going to write down all the possible outcomes. So we could have a head on the coin with a 1 on the spinner. We could have a head and a 2. Could have a head and a 3, head and a 4, could have a head and a 5, or we could have the following. We could have a tail and a 1, a tail and a 2, tail and a 3, tail and a 4, and a tail with a 5. So that's me writing down the list of possible outcomes. Altogether, we've got 10 in this list. So to answer part A, there are 10 outcomes. The shorter version of doing this would be to say, well, there are 5 outcomes on the spinner. There are 2 outcomes on the coin. 5 times 2 gives me 10 as well. But at least by doing writing out the outcomes, you can see all the possibilities, and it's going to help you with any probability questions. So part B is asking us to calculate the probability of getting a 3 on the spinner and a tail on the coin. So if we have a look, 3 on the spinner, tail on a coin, is that one there? So the probability is just 1, and it's 1 out of 10. And to do part C, it's asking us to find out what the probability of getting a factor of 9. So you need to think, what factors of 9 are there? So factors of 9 are any numbers that go exactly into 9. So that's 1, 3, and 9. So we want to get a factor of 9 and a head on the coin. So we can have a head with a 1 and a head with a 3. Can't have a head with a 9 because there's no number 9 on the spinner. So in this case, we've got these 2 outcomes here. So that will be 2 out of 10. If we simplify the fraction, gives us 1/5. Okay. Section 2 is about interior and exterior angles of regular polygons. So we are being asked to calculate the interior and exterior angles of a regular pentagon. So first of all, we need to know something about a pentagon. And all pentagons have 5 sides. So they'll have 5 interior angles and 5 exterior angles. So here I've drawn a regular pentagon. So if I want to work out the interior angle, it's each one of those in the shape. So it would be helpful if we knew what the angles in a pentagon added up to, or if we had a technique available to us where we can work it out. And that technique is to split the shape up into triangles. So pick one corner. I'm going to pick this one. And when I pick that one, I'm going to join it up to all the other vertices. So there, join it up to there's already drawn, and join it there is already drawn as well. So we can see in here I've got 1, 2, 3 triangles. Something to remember, that to work out the interior angle sum of any polygon, it's the number of sides minus 2 multiplied by 180. That's the number of triangles we can make. In this we've got 5, so it's 5 minus 2 times 180. And we can see clearly we've got 3 of them. So 3 times 180 will give us the sum of 540 degrees. So the angles inside this pentagon add up to 540 degrees. We need to work out now the size of one of these. So if I get rid of some of these lines here and go back now to the original angle here, there's one interior angle. So the total for all of it is 540, and we've got 5 equal angles. So therefore, to work out the size of the interior angle of one of them, and we do 540 degrees divided by 5. In this case, each one is 108 degrees, so 108 degrees. And to work out the exterior is this angle here that's next to it, so on the outside. So what do we know about this? Well, we formed a straight line here, so those two would add up to 180 degrees. Well, part of it's 108, so to find the exterior angle, we take 108 away from 180 degrees, and that gives us 72 degrees. So, part A, interior and exterior. Right, part B then, a regular polygon has an exterior angle of 60 degrees. Well, one of the things that we should know about all exterior angles is that they're all the same size on a regular shape. So if that was 72, this one here would be 72, this one here would be 72 on this shape, until we've labeled them all 72. And if we added up all of those 72s, then 5 72s are at 360. It's because they start in one position and they go right the way around the shape. And if you go right the way around something, it always adds up to 360. So the sum of exterior angles of any shape is always 360 degrees. So if I know then that they're all 60 degrees going around the shape, how many 60s are there in 360? Well, if we divide 360 by 60, it gives us 6. So this shape has 6 sides. And for part C then, another regular polygon has an interior angle of 140 degrees. How many sides does it have? Well, we know if we can find the exterior angle, then we can work with that to work out how many sides there are in the shape. So if we know the interior is 140, then the exterior angle will be 180 minus 140. So the exterior would be 40 degrees. And because it's regular, every angle going around the shape would be 40 degrees until you've done a full turn. So 360 divided by 40 is what we need to do this side. And it's 9, so there would be 9 sides on this polygon. To change the subject of a formula, we need to use our rearranging skills. So we've got a formula here: g equals 3x at 3f plus 5, and we want to make f the subject. First thing I always do is swap the sides of the equation over. So I've got the subject on the left-hand side of the equation, and now I just rearrange it so I get f on its own. So it's 3 times f plus 5 will give us g. So the first thing I'm going to do is take 5 off each side. So if I take 5 away from here, it's gone. On this right hand side, I've got g, and I'm going to take away 5. And that's going to leave me with 3f. And then to undo 3f, I need to divide by 3, because 3f means 3 times f. So I divide both sides by 3. So if I divide g minus 5 all by 3, I get this. And f is now on its own. So f is equal to g minus 5 all over 3. And I've rearranged the formula as I wanted. Similar tact on this one, we're going to make w the subject. So w is on the right hand side. So first job I'm going to do is I'm going to write out the problem with w on the left. So it's w divided by 4, then take 7 off it to get x. So the first thing I'm going to do is deal with the minus 7. So I'm going to add 7 to it to make it 0. So I'm going to add 7 to x. So here I'm going to have x add 7. Over here I've got w over 4. And in this case, to undo divide by 4, we need to multiply both sides by 4. So w will be 4 times all of x plus 7. So we can put it in a bracket, or we can multiply through x plus 7 by 4. So we have 4x plus 28. Either of those versions there is an acceptable answer. And that's how we rearrange a formula. Factorizing then. Factorizing just means to be put it back into brackets. So in this case, we need to look for common factors. That's always the first thing that we look for. It's a common factor. So in this case, there's 2 terms. The numbers are 18 and 24, so we need to think of a factor that will go into 18 and 24. Well, 1 goes into both numbers, 2 goes into both, 3, 4 doesn't go into 18, 5, 6 goes into both, and that's it. So we would choose always to pick out the highest common factor, so we would take out 6 out of the bracket, and then what do we multiply 6 by to make 18a? Well, 6 times 3 is 18, so it would be 6 times 3a, and then 6 times what makes 24? 6 times 4, and that's now factorized. Over here, we just got to be careful because both terms contain the letter y in as well. So first of all, we look at the number 4 and number 12, and we can see that 4 goes into both. But we can also see that there's a y in both terms, so we could take the y out as well. Now we've got 4y, and we need to multiply it by something to make the y squared. So we multiply it by y, and we've got 4y, and what do we multiply it by to make 12y? We multiply it by 3. And that's how we factorize those problems there. Right, standard form then. We want our answers in standard form. So first of all, we write out the numbers into normal numbers. So 6.2 times 10 to the power of 5. That's times 10 once, twice, 3 times, 4 times, 5 times. And 3.8 times 10 to the power of 4. That's times 10 once, twice, 3 times, 4 times. And just set out the problem how you would set out a subtraction. Okay, column method, and then just subtract carefully. So naught take away naught. It's quite straightforward to there. We can't do naught take away 8, so we're borrowing 1. 10 take away 8 is 2. We can't do 1 take away 3, so we need to borrow again. So 11 take away 3 is 8. 5 take away nothing is 5. So we got 582,000. I need to put that back into standard form. So it would be 5.82 times 10 to the power of 5. On this dividing one here, we would need to change the standard form here on the bottom so that it's a whole back into a normal number. So we've got this number on top here, which is 18 million. 6 noughts. 4 times 10 to the power of 3. There's no decimal in this value here, so it'd be 4 times 10 again and again 3 times. So we have this as our problem. So we can simplify this now. So we would look at dividing the fraction here by 1,000. So straight away it would simplify the problem for us. So much simpler. 18,000 divided by 4. So if you're dividing something by 4, you can half it and half it again. So half of 18,000 is 9,000. Half of 9,000 is 4,500. And in this case, now we need to put it back into standard form. So it would be 4.5 times 10 to the power of 3. Okay then, section 6 then is on forming and solving a simultaneous equation. So in this question here, I'm being told that rectangle A has a perimeter of 94 centimeters and rectangle B has a perimeter of 56 centimeters. So first of all, we need to focus on perimeter, which is found by adding all the sides together. So if I'm going to add all sides, it means that this side here is 2x as well. And this side would have length 3y centimeters. On this one over here, this one would be x plus 6, and this would be y plus 4. So if I focus on the perimeter of shape A, we've got this 2x here, and we've got this 2x here, and if I add them together, it gives me 4x. And then if I focus on 3y, and this 3y, add them together, it gives me 6y. So when I add all those sides together, it gives me this expression, 4x plus 6y, and the perimeter is equal to 94. Now, if I focus on shape B, this one has got a length here of x plus 6 and x plus 6. So we can only add together the like terms. So we've got the x plus the x, so that's 2x. 6 plus the 6 is 12. Then if I focus on this term here and this term here, I can add the two y's together, so it gives me 2y, and I add the two 4's together, which gives me 8. And when I add all that together, it gives me a perimeter equal to 56. Now this here now needs to be tidied up, so I need to collect together the like terms, so the plus 12 and the plus 8 can be added together to make 20. So that's how it looks there. But if we're going to solve these now, and we're going to solve them simultaneously because we need to find what x and y is, it's unusual to see to be a plus 20 here. So the first thing that we're going to do is we are going to take that 20 away, but it means we've got to take 20 away from both sides. So if I take that 20 away from here, I've got to take 20 away from the 56 here, which leaves me with 36. So they're my two equations now that I can use to find the values of x and y. And once I've done that, it's asking me to calculate the area of each rectangle. So let's write down then what the equations are. So we've got 4x plus 6y is equal to 94. Let's label that equation number 1. And for shape 2, we've got 2x plus 2y is equal to 36. Okay, now when we solve these simultaneously, we like the coefficients in front of y to have the same value, so they're different, 6 and 2. But I notice that 2 goes into 6 3 times, so I am going to multiply equation number 2 through by 3. So equation 1 will remain the same, and equation 2 I need to multiply this by 3, gives me 6x. I multiply 2y by 3, giving me 6y, and I multiply 36 by 3, which gives me 108. And I'm now going to label these as my equations 3 and 4. Now I can eliminate the y's. They've got the same signs in front, so if I have the same signs, I'm going to subtract. Now, do I want to do 4x take away 6x, or 6x take away 4x? I prefer to do 6x take away 4x because it gives me a positive answer, so I'm going to subtract going up the column here. So 6x take away 4x leaves me with 2x, 6y take away 6y leaves me with nothing, and 108 take away 94 is leaving me with 14. Now I can solve that 2x is equal to 14, so if I divide through by 2, I know that x is equal to 7. At this stage now, I need to find what y is, so I need to substitute x equal to 7, and I'm going to substitute it into equation number 2, because the numbers are much smaller in this one than equation number 1, so easier to work with, hopefully. So I'm going to do 2 times 7 for my 2x, plus 2y is equal to 36. I know 2 7s are 14, so I can work that out. And now I can solve the two-step equation. So first of all, I'm going to take 14 off both sides. So it leaves me with 2y equal to 22. And if I divide through by 2, y will equal 11. So I've now worked out that x is equal to 7 and y is equal to 11. But if you remember back, they asked us to calculate the area of each shape. So if I focus on shape A first, 2x and 3y. Now, if I substitute x as being 7, so x is 7, so 2x would be 14, and then 3y is 3 times 11, so that would be 33. Now I know the area of a rectangle is given by length times width, so 33 times 14 is what I need to work out. So head to the calculator for that one. So 33 times 14 gives me 462. And the units on the diagram are in centimeters, so I'm going to put centimeters squared. And for shape B, again, just draw out shape B. On the top here, I've got x plus 6. And on the side here, I've got y plus 4. And again, if I write those out now with the number, with 7 being replaced for x, so that will be 7 plus 6 will be 13. And 11 for y, so that will be 11 plus 4, 15. And then I would work out 15 times 13 to work out my area, this one, which is 195 centimeters squared. Okay, tree diagrams then. It's always best to draw a diagram on these type of questions, although they'd be usually drawn for you. So, Mr. Thompson then travels to a city away game on the train. The probability of that is 0.8. Otherwise, he travels by car. So he either goes by train or he goes by car. The probability that he does not travel to an away game by train and city win is 0.14. We are being asked to draw a probability tree diagram to show this information. So I'm going to call that T for train. I'm going to call that C for car. So this is just transport. And then this is where the city win. So they either win yes or they don't. Now, we know up here that the probability that he travels by train is 0.8. So I can put that on this branch here. So on this branch here for car, these two branches must add up to 1. So I know the probability he travels by car is 0.2. Now this is where I've got to be really careful, because it tells me the probability that Mr. Thompson does not travel to an away game by train. So not means he must travel by car. And city win is 0.14. That means that that probability times this probability here. So he doesn't travel by train, he travels by car, and city win must be equal to 0.14. So in other words, 0.2 times something must equal 0.14. So to work that out, we can divide 0.14 by 0.2, or realize that 2 times 7 is 14. So it'll be 0.7. And that helps me now fill in the rest of my tree diagram. So the probability that city do not win is 0.3. And we fill in the same values at the top here. So there's my tree diagram all filled in, part A. And for part B, calculate the probability that the next city away game, Mr. Thompson will travel by train. So he's going to travel by train. And city win the game. What is that? So for this one, for part B, I need to multiply 0.8 by 0.7. And I know 8 7s are 56, giving me a final answer of 0.56. Right, to form and solve an inequality, you need to interpret the information and then set it out in the correct way. So first of all, then Mrs. Mills has got n rulers. So we're going to split this up into Mrs. Mills and Miss Edmonds. So first of all, Miss Mills has got n rulers. So she's got n. Miss Mills has got 3 times as many rulers. So she has 3n. Now Mrs. Mills finds 5 more. So she's going to add 5 to hers. And Miss Edmonds loses 2 of her rulers. So we're going to take 2 off. Miss Edmonds has still got more rulers than Miss Mills. So in other words, hers are greater. And we introduce this inequality sign, so the open part would always eat the greater amount. Now, when I'm working with these now, we can start solving this. Now, I like to work with the bigger number of n's on the left-hand side. So 3n is bigger than n. So I'm going to write this out now to help me solve this as 3n minus 2 on the left. But because I've written the 3n minus 2 on the left and the n plus 5 on the right, I need to swap this inequality sign round. So I've done that now, and now I can start solving it. So what do we do when we got a letter on both sides? Then we could take away. We could simplify it. So I'm going to take an n away from each side of the inequality. So taking n away from 3n leaves me with 2n. Still got the minus 2. If I take that n away, it's gone. I'm just left with a 5. I'm trying to get n on its own. So now I'm going to add 2 to both sides. So 5 add 2 gives me 7. So it gives me my next line that 2n is bigger than 7. And then finally, to solve this, I'm going to divide through by 2. So n will be bigger than 7 over 2. Or, if you know what that is as a decimal, it's 3.5. So n is bigger than 3.5. So we've now solved the inequality. What's the least value of n? So n can be a number bigger than 3.5. So n can be 4, 5, 6, 7, and so on. We want the least, and 4 is the least. So the least value for n is 4. Okay, then. Well, section 9 is all about how we evaluate an indice. So it's just remembering the rules really for these. We're being asked to give our answer as an integer or a fraction. So if I've got a power of a half, then a power of a half is the same as square root. So 16 to the power of a half is asking me to calculate the square root of 16, which is 4. If I've got a negative power, I first need to rewrite the information out. So if ever I've got a negative power, I would write it as a fraction first of all. So to do this, it would be 1 over 25 to the positive power of a half. So it removes us worrying about the negative power here. So we would always rewrite this out if we got a negative power. Now 25 to the power of a half, again, we know power of a half is a square root. So we're being asked to work out 1 over the square root of 25, and the square root of 25 is 5. So my answer is going to be 1/5. I'm going to leave that as a fraction. Okay, 64 to the power of a third. So it's a positive power, and we're going to have to do a root, but because it's got a third, it means we're going to do the cubed root. So the cubed root is 64. So what number do we multiply by itself to the power of 3 to get 64? Well, it's 4. 4 times 4 times 4 gives me 64. And this one here doesn't. It's got a non-unit numerator, so 100 to the power of 3 over 2. So on this one, I'm going to bring that power outside. So it's the same as writing 100 to the power of a half and then cubed. So that's the first thing to do there, is to bring that out so that we can focus on finding now 100 to the power of a half. Now, the power of a half is the square root, so we're going to do the square root of 100, and we're going to do the answer to that cubed. Square root of 100 is 10, so I want to work out 10 cubed. 10 times 10 times 10 gives me 1000. Okay, so a negative power, so rewrite it. So that would be 1 over 7 to the power of 1. 7 to the power of 1 is just 7. So 1 over 7, leave it as a fraction. Again, a negative power, so let's rewrite it out. 1 over 11 squared. 11 squared is 121. It's going to be 1 over 121. Again, leave that as a fraction. 27 to the power of minus 2/3. So again, we've got this negative power here. So we need to rewrite this first. So it'll be 1 over 27, and it'll be to the power of 2/3. Now again, we haven't got a unit fraction here with a power. We've got 2/3. So I'm going to rewrite this as 1 over 27, the power of 1/3. So we're going to find the cube root of 27, and then I'm going to square my answer to that. So what's the cube root of 27? Well, it's 3. 3 times 3 times 3 gives me 27. And I'm now going to square it. And 3 squared is 9. So it gives me a final answer of 1 over 9. And then the final one, we've got a 4 here on the numerator. It's not negative. So the first thing I'm going to do is I'm going to rewrite it as 8 to the power of the third. And then I'm going to give that answer to the power of 4. So the cube root of 8 is 2. 2 times 2 times 2 gives me 8. And I'm going to work out 2 to the power of 4. So 2 times 2 times 2 times 2, and it gives me a final answer equal to 16. Thank you very much for listening.